everyone, welcome to my video series on statistical significance testing. So in this video, we are going to talk about the two-way ANOVA test. In the previous video, we talked about the basic ANOVA test, which is also known as the one-way ANOVA test. Now, if you did not follow that video, please go along and check it. I will leave the link in the description because that sort of builds the fundamentals of the ANOVA test. That is why. So in this video, I'm sort of going to assume that you know all those stuff and I'm going to build up from there. So let's get started. So first of all, let's start with the example that we gave in the previous tutorial on ANOVA test. We have these men, Bangladesh, Pakistan, and India. These are three different countries, and these are the heights of their men. So 10 men from Bangladesh, 10 from Pakistan, and 10 from India. And the question is, are any of these height groups significantly different? So it looks like Pakistani people are sort of different from Bangladesh and India. I mean, visually at least, but obviously we need to do some tests we need to do some tests to understand that objectively, and that's why we use ANOVA test. So ANOVA test is used for this kind of stuff when there are more than two groups. For example, here there are three groups, but this question can actually be proposed in a completely different way. Let me show you how. You can actually say, is male height influenced by country of origin? So here, male height is the result and country of origin is actually the one influencing the height. That means it is the effect. Okay. Now, the question here was, why does this example fall in one-way ANOVA category? Question answer is very simple, because height is affected only by one factor, and that factor is the country of origin. But there are a couple of things here you also need to take note of. Number one is the effect, which is the country of origin is actually nominal. So what is nominal? That means there are only three possible values of the country. But the result is continuous because the height can be anything. It can be 3.5, 8.9, whatever metric you are using, I don't know. So those can be heights. So heights can be floating point number. Also, each of this group has approximately equal variance. So that is one of the core principles of one-way ANOVA test, at least for the vanilla one. Now for two-way ANOVA test, we are also going to have these assumptions to be true as well. So let's actually give an example of a two-way ANOVA test now. So suppose we have Bangladesh, we have India, and we have gender as well. We have men and women. So you can see that Bangladeshi man has these heights, these 5 Bangladeshi men. Then there are these 5 Bangladeshi women, 5 Indian men and 5 Indian women. So you can clearly see that now there are two effects. One is the country of origin and the other one is basically the gender. Now you could have more than two country of origins, but just for simplicity in this example, we have kept it to be two. Now, there are a few questions we are going to try and answer from this table. Does country affect height? That is number one. Number two is, does gender affect height? Number three is, does the effect of country depend on gender, or does the effect of gender depend on country? This is also known as the interaction term. Understand this very clearly. We have A, we have B, and we have AB because AB sort of puts these two effects together. So let me show you an example of what I mean by this. For example, BD men are taller than BD women. BD means Bangladesh basically. And Indian men are actually not taller than Indian women. They are sort of equal in terms of height. In this case, you can clearly see that the country of origin is actually affecting the gender behavior. So here, A and B are interacting. Okay. So we also want to answer this question as well. So final thing is the effect of one factor changes depending on the level of the other factor in this example. And that is what we call the effect. So understand that we are going to have three null hypotheses right here. Three. Number one is the country has no effect on the height, the gender has no effect on the height, and last of all, the country or the gender does not really affect each other. Those are the null hypotheses, and we want to prove those things wrong through the statistical significance test, which is known as the two-way ANOVA test. So I know that a lot of things are going on here, but let me explain it slowly. First of all, SS dot is total variance of the dependent variable. Here the dependent variable is the height. SSA is the variance that can be explained by the factor A, and factor A is country. So variance explained by the country. SSB is the variance explained by the gender. SSAB is the interaction term, interaction variance. And finally, SSA is the standard error. So the thing is the total variation I shouldn't really say variance here because it is variation. Variance will be obtained by dividing by the degrees of freedom. So total variation, SS total, is supposed to be a sum of these three things, SSA, SSB, and SSAB. But often you are going to see that it is not. There is some residual term, and that term we call as standard error or SS error. Okay, and each of these variation will have a certain degree of freedom. Each of these variation will have a certain degree of freedom. For example, this one will have DFA, this one DFB, this one DFAB, this one DFA. Okay. So if we want to get the variance, for example, if we want to get the variance of maybe sigma square of A, right? Then in the numerator we are going to put SSA, and in the denominator we are going to put DF of A. That means divided by degrees of freedom of A. So these are pretty simple things. Every person who knows basic statistics knows about these things. Now, there are several questions. For example, how exactly are we going to get these? So I will get to that gradually. Now, assume that you know these terms, you know the degrees of freedom, and you know these sigma squares, right? In that case, you can very easily get the F statistics. FA, FB, and FAB, because we have three null hypotheses, we can get the three statistics. And every one of them will be divided by sigma square error, because that is basically the rule of getting the F statistic, right? We basically try to divide the actual variance, the variance that we're interested in, divided by the error or the noise variance, basically. And each of these will have a degree of freedom, suppose D1 and D2. And we can actually draw this kind of plot. So here, this is a F distribution plot. I have shown this plot in the previous video as well, so I'm not going to talk a lot about this. So just to summarize, D1 and D2, their value sort of dictates the shape of this curve. And suppose we are looking at the green case where D1 equal to 5 and D2 equal to 100. And if our F value is somewhere around here, 1.8, then everything that is to the right, the whole area, will actually give you the p-value. So here it's quite a big area. Thus the p-value is 0.25. Since p-value is 0.25 and it is greater than 0.05, that is why we cannot reject the null hypothesis. Okay. So we have to actually look into this curve for FA, FB, and FAB. And based on the value right here, whether it is less than 0.05 or not, either we are going to reject the null hypothesis or we are going to just accept it. Okay. That is the game. Now, I think everything is clear, but the only thing that is not clear to you is how exactly are we going to get these four values, right? So that is exactly what we are going to discuss right now. So let's dive in. So two questions, how do we get these and how do we get the degrees of freedom? Okay, so let's see an example. So same example as we gave in the first slide. So we have Bangladesh, India, and men and women right here. So we have two kinds of groupings, country and gender. You can see that for each group, for example, Bangladeshi men, the average is 171, Bangladeshi women, average is 159, and so on and so forth. We can also get the average for all men, for all 10 men, regardless of which country they belong to, and that is 173. Similarly, for all women, it is 160. Similarly, we can get the average height for all Bangladeshi guys. Bangladeshi people, whether it is man or women, doesn't matter. So if we get the average of these 10, it is 165. And if we get the average of these 10 for India, it is going to be 168. And the grand mean is nothing but average of everything. Average of everything. So the first thing you need to do is you need to prepare this table where you have the grouped means, the category-wise means, and the grand mean. Okay, this is the first step. And let's assume that this is grouping A and this is grouping B. Okay, just for simplicity, basically, because we are using A and B right here, that is why. So let's first see how do we get SSA, right? SSA. So the first thing is SSA is basically the variance explained by the country. So what we are going to do is we are going to take the country means 165 and 168, and we are going to look at the deviation from those to the grand mean. So 165 minus 166.5 whole square plus 168 minus 166.5 whole square. We also have to multiply it by 10. Why? Because each of this mean corresponds to 10 values. So this mean is a representative of 10 values. This mean is also representative of 10 values. That is why we multiply by 10. So it is going to be 45. What is degrees of freedom? There are only two groupings, right? There is the mean of Bangladesh and there is the mean of India. There is the grand mean as well. So if we know one of these means and the grand mean, then we can easily derive the other one. That is why it is going to be 2 minus 1 equal to 1, because there are two things and n minus 1 is the df. And then we can get the sigma a square by dividing 45 by the 1, which is equal to 45. And in the exact same fashion, we can get the SSB and the sigma b square. So I am not going to do the detailed math, just to give you the idea. So we need to look at the gender means right now, 173, 160, and the grand mean. Same thing, we are going to have to take the deviation, 173 minus 166.5 whole square and 160 minus 166.5 whole square. Add them up and multiply them by 10, because each mean represents 10 heights, right? 10 heights, that is why. So if we do the math, we are going to get some number which is going to be SSB. And obviously here as well, we have only two categories, male and female. And so the degrees of freedom will be 2 minus 1 equal to 1. So we now know SSA and SSB. Okay, now let's, not SSA and SSB only, also sigma a square and sigma b square basically. Now let's look at SSAB, right? SSAB. So in order to understand SSAB, we need to understand this line very clearly. The total variation between different forms of groupings. So different forms of groupings means what? It means Indian man, Indian women, Bangladeshi man, Bangladeshi women. Those are the different forms of groupings. It is the sum of group-specific variations, that means country-specific and gender-specific variations, and the interaction between the groups, that means interaction between country and gender, right? So if you sum those two variations up, you are going to get the variation between different forms of groupings. So let me actually show you this in perspective. So SS between groups is equal to the sum of all these three things. That means SSAB equal to this. So I have just side changed here, nothing else. But we don't know SS between groups. We know SSA and SSB from previous two slides, but we have no idea about SS between groups. So let's see how exactly are we going to get this one. So in order to get this one, as I said before, we are going to consider all possible groupings. So there are four possible groupings, that is Bangladeshi man, Bangladeshi women, Indian men, and Indian women. And their averages are 171, 159, 175, and 161. And this is the grand mean. And every one of these means actually represent five numbers, right? So I think you know what we are going to do. We are going to multiply by 5, and we are going to take the deviation of each of these four numbers from the grand mean. If we sum these things up, we are going to get the 895. So now we just have to plug in these numbers. If we plug in these numbers, we are going to get 5. Now this is the important part. How do we get the degrees of freedom for the interaction? It is very simple. So the degrees of freedom to get the degrees of freedom for both interacting variables and multiply them together, because it's sort of like cross, right? So if we do that, then we are going to get 1 into 1 equal to 1. Unfortunately, it didn't increase. So the sigma square AB will be 5 divided by 1 equal to 5. So we now have SSAB. So the last part is remaining, that is SSERR. That means SS error, right? So how do we get that? Again, this formula we have seen at the very first, right? We know that the total variation is equal to the sum of all these things, and SS error is the part which we cannot explain. And so SS error is nothing but this. Now the question is, we know all of these three things, but we don't know SS total. So how exactly are we going to get SS total? So this is basically our total table. And in this table, you can see that these are all the individual numbers. So here for SS total, we are going to consider all the individual numbers, right? So we are going to get the difference between 170 and 166.5, 172 and 166.5, 168 and 166.5, and so on and so forth. And we are going to sum up everything. Now there is no multiplication right here, because each number represents only one number itself, nothing else. Great. So now that we know all of those things, we can actually get the SS total, which is going to be 1100. And here, the interesting thing is SSR is 205, but the main interesting thing here is the degrees of freedom. So let me talk about that. So degrees of freedom of the error term is 20 minus 4. Now why is that? Because there are 20 samples right here, that is fine, but there are also 4 group means. And they sort of cancel out 4 degrees of freedom, because those 4 variables we can do without, we can just infer them from the 4 group means. That is why. So that is all about basically getting the SS error and the DF error. So finally we can get the sigma square error, which is equal to 12.5. So now that we know everything, we know sigma square A, sigma square B, sigma square AB, sigma square error or error, we can very easily get the F values, FA, FB, FAB, we can get the P value, and we can get our 3 significance results. And that is how the two-way ANOVA test is done, my friends. So if you like the video, feel free to subscribe and share. And you can donate to our channel if you like the video via the link in the description. Thank you very much.